Dear all, in today's session we are going to see design a simply supported beam of a rectangular section with clear span of 6.5 meter and subjected to a uniformly distributed live and superimposed load of 20 kilonewton per meter and 15 kilonewton per meter respectively at service state, and the support width is 500 mm, and the materials used are M20 grade of concrete and Fe415 grade of steel. So first step is we need to write the given data. So the given data are clear span, that is L is 6.5 meter, and we have a load of live load is 20 kilonewton per meter, and superimposed load is 15 kilonewton per meter, is 15 kilonewton per meter, and we have a support width of 500 mm, 500 mm, and we are going to use M20 grade of concrete and Fe415 grade of steel. So the first step in this problem is we need to calculate the basic dimensions of the beam. So the first step is basic dimensions. So from IS 456 page number 37 we have the formula relationship, that is L by D equal to the ratio is there. If it is cantilever it is 7, and if it is simply supported the value is 20, and if it is continuous the value is 26. So here it is a simply supported beam, so the value will be L by D ratio is 20. So you can check it in page number 37 of IS 456. So here I am going to substitute. I need to find out the value D. So D equal to L divided by 20. So L is nothing but 6500 mm divided by 20. So the value is 325 mm. So I need to calculate the overall depth, that is capital D. D equal to D plus cover, effective depth plus cover equal to the value will be 325 mm, and the cover for beam is minimum required is 25 mm. So I can take it as overall depth as 350 mm. So this is nothing but your effective depth, and this is nothing but your overall depth. So next step I need to calculate the effective span. So effective span formula is I can take L plus D, that is clear span plus effective depth, or L plus support width, that is in codebook if you see it will give it has been given as center to center distance between the support, that is span plus half of the support on the right side and half of the support on the left side. So here if you see L is nothing but your value is 6500, and plus depth is here it is 325 mm, or I can take it as L is 6500 and they have given the support with us 500 mm. So here if you see we get the value as 6825 mm or 7000 mm. So as per our code book we need to take the smaller of these two values. So I can take L effective as 6825 mm. So next width of the beam 300 mm. So next step is load calculation. So in order to calculate the load, first step is self weight of the beam, that is self weight of the beam. It will be given by the formula L into B into D into unit weight of concrete, which is 25 kilonewton per meter cube. So L we can take it as 1 and B is 0.3 and D is 0.325 and into 25. So the value is 2.34375. So I can take it as 2.48 kilonewton per meter. And next one is live load. Live load they have given it as 20 kilonewton per meter, and they have given the superimposed load. Superimposed load is 15 kilonewton per meter, and I need to take the floor finish load. Floor finish load is Generally for beam we can take it as 1 kilonewton per meter. So the total value will be, so here the value is 2.44, not 2.48. So the total value is 38.44 kilonewton per meter. Here they have mentioned it as service load. So the load we need, the load which we have calculated is nothing but your working load or service load. Working load, or I can call it as service load. So in order to calculate the design load, I need to convert this into design load, that is ultimate load. So the formula which we can use is, we need to multiply this value with partial safety factor. The partial safety factor for a beam is 1.5. So here the design load is, we can call this design, or another name is ultimate, or we can call this as factored load. So we need to multiply 1.5 into 38.44. So we need to multiply the service load with the partial safety factor of 1.5. So the value which we are getting is 57.66 kilonewton per meter. So next step is we need to calculate the bending moment and shear force. Since the given beam is a simply supported beam, we can calculate the bending moment by using the formula WL square by 8. So mu equal to WU L effective square divided by 8. W is nothing but your ultimate load. So here we can use the notation WU. So here the value is 57.66 into L effective is 6.825 square divided by 8. So the answer which we are getting is, the value which we are getting is 335.73 kilonewton meter. Next, in order to calculate the shear force, the formula is VU equal to WU L effective divided by 2. So here the value is 57.66 into 6.825 divided by 2. So the value which we are getting is 196.76 kilonewton. So next step is we need to check for the mu limit. So mu limit equal to, since it is Fe415, so we know the value 0.138 FCK BD square. So here 0.138 FCK is M20 and B is 300 and D is 325 square. So the value which we are getting is, 85.457500. This is in terms of Newton meter. So if we want to convert this into kilonewton meter, so the value will be 85.458 kilonewton meter. So here it is in Newton mm. So since mu limit is less than mu, so the section need to be designed as doubly reinforced beam.